I'm going to go ahead and get started because I know that it is past the school bell here. Yeah, and some people will still keep coming in, but there's good news, and that is they gave me a MacBook Pro, and it's got such a better camera. I can just directly put it to the smart board here, and it also has much better speeds. Originally, they thought the lag time between when I talked and when you guys could hear me was because of the speeds of the servers. But the tech people said, no, it's actually the computer. So after trying 2 different Chromebooks that weren't capable of all of this, they gave me a MacBook Pro. And I hope you guys are seeing the board a lot easier. We're still going to have trouble with this neon green business that they have there, but my green marker will work now because you can see that now. So hopefully all of the bugs are worked out and we'll be able to have a kind of normal class. Normal for distance learning anyway. All right, so today we are still working on section 4.2. We're doing a second day on this, graph quadratic functions written in standard form. And as hopefully you heard on video yesterday, since we had so much trouble with seeing and hearing during the lesson, we have another day on this. And at first you'd say, well, why do we get another day on this? We totally know how to do it. It's that x equals negative b over 2a formula. You find the x, you plug it in, you get the y. We know all that, see it at home. Because it's so much easier to graph in vertex form and understand what's going on in vertex form. So one of the things we're going to focus on today is, if it comes in standard form, could we force it into vertex form? And the answer to that is absolutely, yes, we could. So we're still working on that objective. We're just learning different chunks of information. And what those chunks of information do is they allow us to say, okay, I've learned this little new piece. Now let me figure out how that fits in. And then we'll learn another chunk and see how all of that fits in. So here was 4.1. That was vertex form. Y equals a, and then we had the quantity x minus h squared plus k, and we remembered from doing absolute value with the same formula that it's always the x that has to be the little brat and is the opposite of what we always think it should be. So if it says x minus 3, it actually went 3 to the right. And so our vertex, basically the only trouble with the vertex is remembering that that x is the opposite of what it needs to be, because we can see the k right in the back there. And now yesterday we talked about standard form. And in all honesty, most quadratics come to us in standard form. Y equals ax squared plus bx plus c, that's how they come. And then we have to do a little bit more work. So we have to do negative b over 2a. We find a, we find b, we find c, plug them in, simplify it, and then we have to put that back into the original formula. So the notation for that kind of helps us remember we're going to put negative b over 2a back into f in order to figure out what we get for y. So it's not a complicated formula. Like I mentioned before, you learned this one in exponential. It's just a little bit harder to remember than vertex form, you know? And since vertex form is so great, we'd want to use that a lot, if possible. So now, what we're going to do today is convert standard form to vertex form. We're going to use what I call the educated cheat. Now, the reason I call it that is because we're really not doing all of the algebra that's required to make this go from standard form to vertex form. That comes later in this chapter. We're really just saying, well, if I know how to find the vertex, can't I just cheat and find the vertex and then put it in there as h and k? And the answer is absolutely you can. I mean, that's why it's the educated cheat. So this says, what is the vertex form of y equals 2x squared plus 10x plus 7? And the first thing I do is realize, hey, a is 2, because it's y equals ax squared plus bx plus c. and B is going to be 10, and C is 7. And then I remember my little formula, x equals negative b over 2a, so negative 10 over 2 times 2, still have some math to do in the denominator. 2 times 2 is 4. And then I realized, well, I could simplify that. I could divide the top and the bottom number both by 2. So I get a fraction. It's not an awful fraction, but it's a fraction. So for my vertex down here, I can put in negative 5 halves. And speaking of I can put in, I now have to take that negative 5 halves and I have to put that back into the original equation. Let me circle that in red up here so we don't lose track of that one. That was the original equation. So I'm going to do it by hand, but then I'm also going to show you, if you just want to use a calculator for this, that you totally can do that. So by hand, we had y equals, oh, you know what? In fact, I'm not even going to put this on the same page because I don't want you to confuse that with the vertex form. We had y equals 2x squared plus 10x plus 7. And we now know that for our vertex, we had negative 5 halves. So what I have to do is plug that negative 5 halves in anywhere that there's an x. And then I do the math following the order of operations to see what I get. So the first thing I have to do is deal with this exponent, this power. And I realize, well, negative 5 halves squared is just negative 5 halves times negative 5 halves. And with fractions, you always do top times top, bottom times bottom. So it'll be 2 times 25 fourths. And then I'm still going to do 10 times negative 5 halves plus 7. But again, order of operations said take care of the exponent first. That's what I did. So now I go back, and the next thing to do would be multiply and divide from left to right. Well, I can either do a little reducing here with the 2 and the 4, because a 2 goes into both of those, or I could multiply 2 times 25, get 50 fourths, and reduce that. Here I can take the 10 and the 2 and do a little reducing, and then I'll have 5 times negative 5, which is negative 25, plus 7. And then I have 25 halves, negative 25 plus 7 is minus 18. And then I need a common denominator for these two. And right now this is 18 over 1. So what I have to do is multiply the top and the bottom by 2, and that would give me negative 36 halves. Last step, 25 minus 36 is negative 11. Phew. All of that by hand. Now, let me show you what I would do if I wanted to put this in the graphing calculator and let the calculator take care of all of that for me. So I'm on my main screen here, and I'm going to punch in the 2 parentheses, and then remember we had negative 5 halves, so negative 5 divided by 2 parentheses squared, and then we had plus 10x, so plus 10 parentheses, our x again was negative 5 halves, and then we had the plus 7 in the back. And then I let the calculator change it back into a fraction for me. Math, number 1, enter. Look at that, negative 11 halves. Now, this is probably the faster way, but you have to make sure that you're getting the right answer, and the way that you do that is by making sure you're using parentheses whenever you put that negative in there, so everything works out like it's supposed to. So, back to the problem. We now know that if we put negative 5 halves back into that equation, we get negative 11 halves. that gives me the y coordinate for my vertex. And if I know A, H, and K, well, then I can write it in vertex form. So I guess I'm thinking, did I know what A was? And the answer to that is absolutely. We wrote it down right up here. It was 2. So y equals A times the quantity x minus h squared plus k. Y equals 2, and I scrolled it up too far. I want you to be able to see the vertex there. And then I remember, oh wait, it's got to look the opposite though. So if it's negative 5 halves in here, it's going to be plus 5 halves. The k in the back, that one's just normal. So we'll have the minus 11 halves in the back there. And now it's in vertex form. You may have noticed what took the longest about this whole problem was finding this negative 11 halves. And again, if you want to do that totally with the graphing calculator, feel free to do that. When we test, those of you that are saying to yourselves right now, gosh, I don't have one of those graphing calculators, and if I don't have one, well, how am I going to do the test? Because I'm going to watch you take the test on Google Meet, and I'm going to use GoGuardian. You can use that online TI-84 Plus. So get used to using that little app, and things will go great when we get to this. Again, put parentheses in whenever you put that negative in there. So now, we are to the next one of these. We're getting standard form, and we want to put it into vertex form. So please, unmute. I'm really thinking this is going to work today. Unmute yourselves so that you can help me as I'm asking questions. Okay, I'm waiting. There's still a lot of red mutes on there. All right, here we go. What is the vertex form of this? Well, to start, we need A. What's A?
-1.
It is. What's B?
4.
4. What's C?
-5.
Excellent. And then we find the vertex. It tells us right here how to do it, but I'm guessing after yesterday's homework you kind of memorized that by accident anyway. So -4 over 2 times -1 will be -4 over -2. What does that simplify to?
2.
1/2.
Oh, careful.
2.
Yeah,
You're right.
there we go. Now what did we just find? What is that 2? What's it stand for?
The x for the vertex.
It is, and it's also x equals 2 is going to be the axis of symmetry. So we need to take that 2 and do what with it? Look back at the last problem. What are we going to do with that 2 so that we can finish up the vertex?
Plug it back in.
So it's going back up here, and that'll give us y equals -2 squared plus 4 times 2 minus 5. You can use a calculator for this. Like I said, it's just a great practice to always use parentheses if you're going to stick those back in and let the calculator do it. But order of operations says 2 squared is 4, so this will be -4 plus 8 minus 5. -4 plus 8 is 4, and 4 minus 5 is -1. So, kind of an educated cheat. If we know how to find the vertex, of course we can put it in vertex form. So y equals, what was A again?
-1.
-1. So I'm just going to put the negative out in front of here. And we have to be careful with this one. What's that going to look like in the parentheses?
X minus 2.
Good. And what do we tag onto the back?
-1.
Yep.
-1.
Yeah, -1. There it is. So now it's in vertex form. Like I said, it's not really doing the algebra that would make it go from standard form to vertex form, but what it is doing is it's an educated cheat. We found the vertex, we know what A is, and we put them in. Works for now. I'm going to get a little bit more background, so that was a big chunk of information right there. And while there were probably 6 people talking on one of those, I sure would like it if everybody did. You can go back on mute for just a little bit here. We're going to talk through this word problem. And this says, interpreting a quadratic graph. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function, and you're going to notice it's got nasty decimals. That's because life is never pretty. Life never has those nice integers for us. Y equals negative 0.000498x squared plus 0.47x. Where x and y are in feet. How high above the river is the arch? Okay, so here's the arch. Here's the bridge. Again, the big deal about this is it's just one arch. It's the longest one arch bridge that we have. And it shows us that from the river to the bottom of that bridge is 516 feet. But what we don't know is, what's the height of the arch above that? Because they want to know, how high is that up? And then it says, how long is the section of the bridge above the road? So we also want to know across, how far is that traveling? So I start thinking, well, this is really just about the vertex. Because if I can figure out my x and my y right up here, the x value is how far the bridge is halfway across. And the y value is how high it is. So I just need to find the vertex, and then I can reason through all these numbers. But this really bothers me. It's missing something. It's missing a C. So I want you to unmute for a second and tell me if there is no number in back, if we're supposed to add something that's nothing, what are we really adding back there?
0.
Yes, exactly. And we don't use C to find the vertex anyway. So it just makes us feel a little better that everything's there, but it's not something that we use for this. Now that looks like a 10. Let me go back up there. That was 0.8447. Alrighty, so I'm going to find the vertex. X equals negative b over 2a. And again, not too pleased about the numbers here, but we do know that b is 0.847. And it is negative because it had the subtraction. Wait a second, no, it was positive. That's what my 1 was over here. It was my plus that was missing. There we go. And then on the bottom, we'll have a negative 2 times 0.000498. Negative 0.00498. I always have to make sure I get enough zeros on there. 1 in front, 1, 2, 3. Got it. And we punch that into a calculator. I don't think anybody wants to do that by hand. So we had 0.847 divided by parentheses, negative 2 parentheses, negative 0.000, sure I have all my zeros in there, 498. Parentheses, parentheses. So that way the calculator knows the 0.847 is on the top by itself, and all of this stuff is on the bottom. And I hit enter. And it's pretty doggone close to 850 feet. I think I'm just going to use 850. That's probably too small for you to see. Let me make it really big. So now I can tell them how far across it is, but that wasn't the first thing they asked me for. The first thing they asked me for was the height. So that comes from the y. So what do I do with that 850 so I can find the y? Go ahead and unmute yourself so you can answer me.
Plug it back in.
Exactly. Unfortunately, we got to plug it back into that really nasty equation. So we need negative 0.000 498 parentheses 850 parentheses squared plus 0.847 parentheses 850. Whew. And that's super close to 360. So let's use 360. Can you read it when it's in this little box, or is that too small? Somebody unmute and let me know. Can you read this in the little box?
So small.
Yeah,
Is it too small? Okay, so I'll make sure I'm always writing bigger on this. All right, well, now our job is to actually answer their question. And we can see here that what we just found was the height, that 360. But then I remember from the picture, from the river up to the bottom of where we were calculating that arch is 516. So I'm going to have to take 516 plus 360 to get the height all together. So what do we have? 876 feet high. And then later on, it said, how long is the section of the bridge above the arc? Well, let's think about that. So over here was 850. Are we supposed to know what this is? If this was 850, what's this stretch on this side?
850.
Exactly. They're both 850. So we could just take 850 times 2. (1,700 feet long. Now we left off some decimals, so our answer's not perfect, but it's pretty doggone close to what we would need. So again, came in standard form, not the most beautiful equation in the world. In fact, I keep having to fix this. That green is bothering me too. I don't know, I might still stay away from green. Question, hopefully everybody will answer for me. Can you see this green?
A little. There's a glare right in the middle.
Is there? Okay, so maybe I'll just keep staying away from the green like I did the last couple of days and use the other ones since they're darker, easier for you to see. Alrighty, so there's our word problem chunk. And we'd think, okay, we've got it, because usually when we're done with word problems, we're done with it. But in your homework, there are some problems that are like little math puzzles. They give us some of the numbers and ask us to find the other ones. And what we always want to think is, well, what are all the formulas that I know here that I could use to find the things that are missing? So this says for each function, the vertex of the function's graph is given. So that's our vertex. Find the unknown coefficients. Oh, so it looks like I have to find A. Hey, they gave me B. B is 10, but I don't know what C is. All right, here's the problem. If we have two unknowns, then we need two equations to solve it. And that's the stuff we did in chapter 3, but that's a little tougher than if we were just solving for x. I mean, if we only have one unknown, then we'll be better off. So what I'm trying to think about is, do I have something that would just use b, x, and y that would also have a in it? So something that uses b, x, and y, or some of those, and also has a in it. Anybody remember a formula from yesterday that would have b, a, and x in it? Take a peek back. Look for a formula that has b, a, and x. When you find it, unmute yourself and let us know. Has to use b, a, and x.
Is it the y equals ax squared plus bx plus c?
No, but you're getting closer, Amos. You're so close. B, A, and X.
X equals negative b over 2a.
Beautiful, Haley. There it is. X equals negative b over 2a. And I know an x, the x is negative 5. I know the b, it's 10. I need a. And notice that only has one variable in it. That is going to make this a lot easier. In fact, if we put a 1 underneath here, we can use that as a proportion and we can cross multiply. This problem's almost done. This will give us a negative 10a equals negative 10. We'll just divide both sides by negative 10. And we just found a. A is 1. So now I start thinking, it wasn't just a they wanted me to find. I also have to find c. Do I have enough stuff now that I could just have c as my variable? Let's see. Here's c. Oh, I have an x. X is negative 5. I can put that in both of these spots. I now know what a is. A is 1. And I know what the y is. That's negative 27. If I put all those numbers in, I can figure out what c is. So y is negative 27. A, we just found it was 1. X is that little negative 5, so I'm going to put that in 2 spots and leave myself enough room to write. And then I need my little plus c in the back. And then we'd follow the order of operations. Negative 5 times negative 5 is 25. 10 times negative 5 is negative 50. Now we need to add and subtract inside there. We could take 25 minus 50. That'll be negative 25. Last but not least, let's add 25 to both sides. Hey, we just found C. So like I said, there'll be 1, 2, 3 of these in the homework. They're just kind of little math puzzles about, hey, what are all the formulas that I know and which one would be the right one to use so that I just have one variable missing. We don't want 2 because then we have to try to find 2 equations and that's going to be really hard to do in this process. So 1 variable only. All right, we are going to fill in this fabulous review chart here of section 4.1 and 4.2, because we actually just learned the last chunk of information that we needed off of the homework problems. So now, we've covered parabolas and quadratics for a total of 4 days. Does anybody want to tell me what standard, you know what, I'm not going to put it that way. Somebody please unmute your mic and tell me what standard form looks like.
Y equals ax squared plus bx plus c.
Fantastic, Emma. Perfect. Y equals ax squared plus bx plus c. Originally, remember, we were going to stop at 4.2 and take a test on these two sections. Now we're going to keep going because we had those 3 days off. That way we can get all these nice reviews in here. Alrighty, next one I'll need, the axis of symmetry when it's in standard form. Let's go down here and do it vertically first. So how do you find the axis of symmetry if your equation is y equals ax squared plus bx plus c?
It's x equals negative b over 2a.
Beautiful, Caleb. There it is. X equals negative b over 2a. Now if we have the axis of symmetry, how do we get the vertex?
Plug in what you got for x and then solve for y.
Exactly. You just got that x equals negative b over 2a. That one does double duty. It's both the axis of symmetry as a line, x equals whatever it is, and it is the x coordinate of the vertex. And that's because our axis of symmetry always goes through the vertex. All right, this one, we might overthink it for a second, but remember this was a really easy thing to find in standard form. What is the y-intercept?
C.
And as a point, it's 0c. Now, where do we find the maximum or the minimum of a standard form parabola? Where
The
is
vertex point if x is positive or negative.
the vertex point? Now, they always just focus on the y because we just want to know how high up or how low it is. But remember that maximum or minimum is actually exactly the same as the vertex up here if you want both the x and the y coordinate. You already found it. That's where your maximum or your minimum is. And absolutely, is it opening up? Then it has a minimum. Is it opening down? Then it has a maximum. So it's all about the up or down pieces. All right, let's go to the next one over here. We've got vertex form. So I need to know what the standard look is in vertex form.
Y equals a times the quantity x plus h squared plus k.
Oh, so close. Can you catch yourself? There was a sign error. Help out somebody. Oops, Emma, you got it?
Minus h?
Yes, yes. Yeah, that's that x is always backwards from what we think it's supposed to be going on there with the x minus h squared. Now, let's do the vertex first because I think that'll help out a little bit. So let's jump down to this space. How do you find the vertex in y equals a, the quantity x minus h squared plus k? Where's the vertex? Come on, everybody, this is in vertex form. Where do we find the vertex?
H and k.
Exactly, Ashley. There it is, h and k. Now, if that's the vertex, and our axis of symmetry always cuts through it, what would our axis of symmetry formula be for vertex form?
X equals h.
Perfect. Has to go through the x-coordinate of the vertex. It has to. Now, this next one, the y-intercept, we didn't really talk about when we went through this section, and that's because Sometimes we'll put 0 into our tables and get that as a number, but most of the time we just have to see where is the axis of symmetry, where's our vertex and all of that. So I'm going to give you this one. This is a little tougher because what it's saying is you have to take 0 and put it into the formula for x. And that's the way you figure out the y-intercept. That's not something we use a lot, so I wouldn't memorize that formula at all. Because like I said, we're going to make the shape of the graph first, and that's going to determine how the graph is going to look. And then maximum or minimum. Now think about vertex form and all the stuff that we had up here. With vertex form, where is the maximum or the minimum? Question is, in vertex form, where do we find the maximum or the minimum?
At the vertex, going down.
At the
right?
vertex, yeah, HK. So again, the book is going to focus on K because that's the height piece. You know, we want to know how high or how low is this? And that's why it's maximum or minimum. Well, that's everything we've covered in 4.1 and 4.2. We did standard form and we did vertex form first because that's the preferred one. We really like to use that all the time. Now, before I give you the homework, I need to remind you how important it is that you're doing the homework. Yes, you and I both know that I've got all the answers posted for you on Schoology, but without the practice, you guys know this, I've harped on this before, it's not going to go from short-term memory to long-term memory. Now, we've shortened these assignments as much as we possibly can to make sure that you're still getting enough so you could go on to college algebra or pre-calculus next year. But you have to do them. You have to. And try to keep up with them. And our first test is a ways off yet. In fact, somebody just reminded me this morning, it's like December 8th is when we take the test on 4.1 to 4.5. So we've got to lock that stuff into your long-term memory so that it'll stay there until we come back after Thanksgiving break. So, 4.2, day 2, there you are. 27 to 31 the odd, 34 to 38 the even, 43 to 47 the odd. And admin has said they would prefer if everybody just stayed on the Google Meets. And until when for third hour? Until 10:45 in case you have any questions as you're working through the homework, which is probably a good idea because that way, you know, I could do them up here where everybody can see them. So you can go ahead and get started and give me a holler if you have a question you want me to do up here on the board for everybody. I guess I better stop the